Hello everyone, welcome back to my channel. Today I would like to explain about what is Josephus problem. Josephus problem, there will be n people in a circle. Let us take an example of n equals to 5 and with index 0, 1, 2, 3, 4. And in each iteration, the kth person will be killed. Here let us take a k equals to 2. And in first iteration, the second indexed person will be killed. That is, second person from the start will be killed. And the iteration starts from the next person. Here, the third person will become the first person in the next iteration. So the zeroth indexed person will be killed in the next iteration. And the fourth indexed person will be killed in the next iteration. And the first indexed person will be killed in the next iteration, and the final person who is left in the circle will be 3. This is the output which is required in the Josephus problem. And to be more clear in theoretical wise, this will be like n people in a circle, and in each iteration kth person will be killed. Let us see the better explanation for this with an example of 0, 1, 2, 3, and 4. And this will be the function called of 5 comma 3. Here and 5 is 10 and k is 3. And after the first iteration, this will become as 0, 1, 2, 3. This is our hypothetical assumption that the circle becomes like this. But the real happening behind this will be that after killing the second index person in the first iteration, the index of the persons will be changed. That is, 3 will become 1 and 4 will become 2 and 0 will become 3 and so on. Like, but we should not change the index of the person, so that we need to do something to overcome this drawback of the recursion problem. That is by adding something to the answer. Like here, if you see for 5 comma 3 recursion call, 5 comma 3 calls 4 comma 3. That is in 4 comma 3 function, if it is 0, the answer should be 3. Thus, if it is 1, the answer should be 4. And if it is 2, the answer should be 0. And if it is 3, the answer should be 1. So from this, we can see that if 0 becomes 2 and 1 becomes 3 and 4 becomes 1, 3 becomes 3, 3 becomes 0. Sorry. This is what happening in each iteration, each recursive call. And let us see the general way of this. There will be n people in a circle, and let's take this as k and k minus 1, k minus k plus 1. And after one iteration, the circle becomes with n people, n minus 1 people. If the function returns 0, the answer should be k. And if the function returns 1, the answer should be k plus 1. If the function returns 2, the answer should be k plus 2. Now we can see that we should add k for the answer we get for the next recursive call. So for this, I will explain two approaches, using one using array list and other using recursion. Coming to array list, let me declare an array list of integer data type, of name equals to name, and so on. And first, I will add all the values into the array list. Now, I will take an index. While the size of the array is greater than 1, because we need to make the size of the array as 1, and the answer will be the remaining value. Index becomes index plus k minus 1 percentile array dot size. Now we need to remove the index. Return answer of print. Now let me trace this part with an example. Let us imagine there is 5 people in our list and k equals to 2. In first iteration, this person will be died and the array list becomes 0, okay, 1, 2, 4, 5, 0, 1, 2, 3. And the second iteration, first index will be died and the array list becomes and fifth indexed person will die and the second index, from the second index it starts, he will die and the answer will be 4. This will be the implementation of a Josephus problem using the array list. And now let us do this with recursion. Recursion is simple compared to array list. That is int Josephus in n integer k. If n equals to 1, we need to return 0 and return Josephus of, sorry, return n and Josephus of n minus 1 comma k plus k minus 1 percentile n plus 1. Here, this is the recursive code for Josephus problem. Now let me take each part and I explain. This will be the base condition. And here we are dividing the each function call with the array size plus 1 because to uh, overcome the or because at each if the index value crosses the limit of the array list size, then we need to bring back the number to the starting of the array list, that is dividing with the array list size, so that it becomes 0 or it returns to the starting stage of the array list. This is the explanation for Josephus problem. Thank you.